In this short lecture segment, we'll apply the concept of double pointers to revise the linked list code from earlier discussions. Go back and look at that prior code and review it, since this lecture is based on it. So, in that earlier code that you just reviewed, we returned a new head pointer from functions like add that modified the list. So this call here in the main would have had head equals add, for instance. That was the only way to pass a changed head pointer back to the caller, at least when we did that earlier example it was. Now, this required assignment of the function's result back into head in the caller is a bit awkward. Our example code here shows an alternative. In every case where head might be altered, we're passing the address of head as a double pointer from the main, and then in the function we can modify head via that pointer, that double pointer, when needed. The diagram next to freeAll, whose code we'll be writing in a little bit, in fact, illustrates the idea. You've got phead pointing to head here. Now, let's look first at the add function on lines 9 through 15, where we've put a diagram that shows the situation at the call of add 40 ampersand head, where we have two nodes on the list already, and then, as we said, phead will point to head, like that. The code uses *phead to reach back to main's local variable head whenever necessary. So tracing that code fully, but quickly here, we can see that line 10 creates a new node and makes RTN point to it, so we get that. And then line 12 will put the 40 into the node. And then, importantly, line 13 copies head, not phead itself, but head from the main, accessing it through phead, and puts that into the next pointer so that this next pointer will now point properly here. And then finally, line 14 changes head in the main to point to the same spot that RTN does, the new node, and we've linked the new node into the list. Now, the remove function also uses *phead, and it has an error, which you're going to be asked to find. Look the remove function over carefully. It does the same kind of standard loop traversal that the earlier version did, looking for a node that has the data we want to find and remove, and that node will be pointed to by temp if we find it. It also has a prior pointer that's supposed to follow temp and point to the node before it. Now, with those in mind, look the code over and answer the question, under what circumstance might line 27 here fail and result in a segmentation fault? And then how would you fix that? So returning from a pause there, if the first node on the list matches value, then prior will still be null. So we need a fix for this, and in the case that the first node is the one we want to remove, the solution is to modify the head pointer to point to the second node of the list. So we'll modify through *phead to accomplish that. And the code we'd add here would be inside this if, a test to see if prior is not equal or is equal to null. And in that case, we're going to need to modify head via phead, and we're going to make it point to the second node of the list, which is the one after temp. Otherwise, we'll do the same code that we already had. So that should fix it, right? Nope. There's still an important error. One line step that is missing. So if you saw that already, great. But if not, pause and think about it and come up with the one line that needs to be added. Coming back from the pause, we need to free the node that we just removed, and do that, of course, only if there is a removal going on. So we'll curly brace this, and something like that would then be a fully correct remove. So that takes care of remove. But freeAll is still unwritten from before. This is supposed to free all the nodes in the list and leave the head pointer set to null. And as before, phead will point to head, so use that. Write the code for free all. And then coming back from a pause here, of course there are several possible implementations. The one I chose did a while star phead, and that of course is checking to see if head is null. And then on each iteration we remove the first node of the list. Make temp point to that first node again, reaching head through star phead, and then change head to point to the second node on the list. And then of course free the node that we just removed. And that would generally work. So you may have found something different. If so, at least look at the code I wrote and be sure you understand it. One change I'd like to make, though. How would the line star phead equal temp arrow next here look if instead we used only phead to accomplish that line? We could do that line without using temp at all, in other words. Revise it so that it replaces the temp with the proper use of phead. And coming back from a pause there, we need to replace temp with the dereferenced phead, of course. But note that the parentheses are also essential, because star has lower precedence than arrow, and we'd need star done first to get to head and then the arrow on the result of that. So question 5. What would happen if the loop test, just to do something kind of wild here, was just phead instead of star phead? How would the code behave? And the answer is badly, but exactly how badly and why? So coming back from a pause there, the loop would never end, because phead always points to head in the caller. If you're testing phead itself, you're asking, is this thing here null or not? Which would never be true. Nothing in the code modifies phead itself. It continues to point to head. So this is another example of how important it is to keep careful track of the difference between a pointer and its target.